All right, welcome back. We are now on the last of our section, section 4.4 before break, and it's an extension of what we did in 4.3, just adding a little bit more. We're going to look at the idea of independence, and we're going to look at the idea of conditional probability. We took the data, or I took the data from the 4.3 lesson and already filled it in. So go ahead and pause this video if you need to fill in the table over here. One other thing is make sure that when you listen to these that you're going on at least 1.5 speed, if not 1.75 or 2.0 speed, because it sounds a lot better. So fill that in, and we're going to go on to number 2. And it starts on number 2 with the phrase given that. I've put them in quotes because that's an important phrase. It says, given that the person selected is a yes evil eyebrow. So I put a check there. Well, if that is the case, we do not have to concern ourselves with any of the no evil eyebrow, nor do we have to look at the grand total, because our new grand total is not 28, it's 18, because we're only concerning ourselves with people who can yes evil eyebrow. All right, so that's what happens when we're in conditional probability, and that's essentially what we're in when we have phrases like given that, or if is another key word, that some condition is present. Then we are restricted to only that condition. We've shrunk the sample space from all of 28 down to whatever the condition is. So we can go ahead and set up this fraction out of 18. So what's the probability that they are a yes taco tongue? Well, here's your yes taco tongue, right? Yes taco tongue out of 18. So that's 13 out of 18, which is approximately 0.722 or 0.722. Right as a fraction, there it is. A decimal, there it is. And as a percent. So that would be 72.2%. All right. Now we have another in number 3, another given that. So given that the person selected is a no evil eyebrow. So now we're over here instead of here. We're no longer on number 2. So we've restricted our sample space down to just this condition. So now we're out of 10. So given that the person selected is a no evil eyebrow, what is the probability that they are a yes taco tongue? Right, that'll be, here's your yes taco tongue, right? That goes across this horizontal. And that'll be 6 out of 10. That's going to be exactly 0.60, which is 60%. Okay, so let's look at a little bit more of this conditional. This idea of conditional probability. It's going to be written probability of yes, this first one, taco tongue, so I'll put the TT, and then you see a line, and that line means given that. All right, so yes, taco tongue, given that they are yes, let me go ahead and write that word out as a yes. Yes, evil eyebrow. And this, the yes, evil eyebrow, is the condition. Okay, down here we have a also probability of yes, taco tongue, but now it's given that it's no evil eyebrow. And we won't be writing things like this. We're expanding it a little bit just so that you can kind of understand. All right, and so this is going to be over, let's see, this is what it was over here, 6 out of 10. And this ends up being the both over the given condition. And that idea of both just kind of leave that aside in your mind for the time being. And that way, when we go and explain it, you can come back and kind of see, oh, okay. So, definition here. Two events are independent if knowing whether or not one event has occurred does not change the probability that the other event will occur. Are the events yes, taco tongue, and yes, evil eyebrow independent? And the answer to that is it is no. And the reason being is that people who can evil eyebrow, go ahead and pause this. So the answer is no, people who can evil eyebrow are much more likely to be able to taco tongue. This is another sort of definition of independence. Knowing that one thing happened doesn't really tell you anything about something else. Here, if a person can evil eyebrow, they are much more likely to taco tongue. That shows a dependency. So if somebody comes in, just one of these people, and you ask them, can you taco tongue? And they say yes. Well, you have some kind of knowledge about what they might also be able to evil eyebrow. Had these two percentages been the same, then if somebody had come in and said, yes, I can taco tongue, you would not be able to say, well, then they're probably more likely to be evil eyebrow also, because you wouldn't have any leaning in one way or another. I don't know if I explained that super well, but that's independence. When proportions are the same, things are independent because you cannot tell them apart based on the other variable. Okay, so let's go ahead and look down here. It says, consider the data for a different class. Suppose that we randomly choose a student from this class. Let's find the following, write as a fraction, a decimal, and a percent. Right. Probability that somebody can yes taco tongue. Remember, yes taco tongue goes this way. So there are 24 out of 30. And if we put that down to, if we simplify that down to a decimal equivalent, that is 0.80 or 80%. All right, what is the probability that somebody can taco tongue given that they can evil eyebrow? Okay, here is your evil eyebrow. Here is your taco tongue out of the total of evil eyebrow. Remember that the given that they can evil eyebrow sort of takes that whole column out. So now this is 8 out of 10, which is also 0.80 or 80%. And finally, C, what is the probability that somebody can taco tongue given that it's no evil eyebrow? So now our condition has shrunk us down to this column because we don't care about whether they can evil eyebrow. We're only concerned if they can't. That'll be 16 out of 20, which is again 0.80, which is 80%. So looking at this, are the yes taco tongue and the yes evil eyebrow independent? Let's go ahead and, well, I put the answer here as a yes, but let's go ahead and look at this a little closer. Probability of yes taco tongue. Let's call that the probability of A. Being able to, the event A is that somebody can taco tongue. And let's call this the probability that they can taco tongue given evil eyebrow. Let's call that the probability of A given B. So this is A, this is going to be B. Okay. Over here, probability of yes taco tongue given no evil eyebrow, this would be event A, and this would be B complement as opposed to B, because this is yes evil eyebrow, this is no evil eyebrow. So we can write this as the conditional probability A given B complement. And if you'll note that these are all the same, 80%, 80%, 80%. So if somebody can taco tongue, they do it at an 80% rate. If they can also evil eyebrow, it's also 80%. And if they can't evil eyebrow, it's also 80%. So what it's saying is that taco tongue is independent of whether or not somebody can evil eyebrow, because the proportions or the fractions or the percentages are the same whether they can evil eyebrow or not. And so that sets up a test to see if events are independent. So are yes taco tongue and yes evil eyebrow independent? That answer is yes, because the rate at which somebody can do it doesn't matter whether or not they can taco tongue or evil eyebrow or not. Let's go ahead and just kind of go off script a little bit and look a little bit more at this idea of independence, because it's not a really hard concept, but people do struggle with it. So I've set up this on a whiteboard, and let's just say I have two events. B is that the couple has a boy, and let's just say that the probability that any couple has a boy is 0.50. And let's call event G that the couple has a girl. All right, so probability of a boy, like we said, is 0.5. All right, let's just say, what is the probability that a couple has a boy given that they had a girl prior to that? So the boy would be the second child. Well, that's going to still be 0.5 because births are independent. It doesn't really matter what happened before. It doesn't influence what comes next. Let's further look at the probability of having a couple having a boy after they had girl complement, which would be a boy prior, right? Because if you don't have a girl, you have a boy. So that's also going to be 0.5. And you notice that it's the same either way. So having a child does not have any kind of dependency on what came before. All right? So if you have had 5 girls, the next birth, there's a 50-50 chance of having a boy. It doesn't matter what came before. If you had 5 boys and your 6th kid, you're wondering, will it be a boy also? Will the fact that I had those 5 boys change the probability and make a boy less likely? And the answer is no, because kids being born are independent. Hopefully that helped to explain this notion of independence. And the way that you do it is to compare the actual outcome of that event to its event given some other event, or given that that other event didn't happen. If they all end up being the same, then A and B are independent. This would be A and this would be B. I think it's time for us to go ahead and have an intermission. So let's see what comes up next. Hopefully it'll be something entertaining. We're on the back page looking at our learning targets, and the first one is to find and interpret conditional probabilities using two-way tables, kind of like what we have down here. And so we're going to put in sort of how conditional probability is notated. So the probability of A given B is the probability of A given that B occurred. And remember, whatever the sample space is, it's going to shrink down to only the given, which is in this case B. And then learning target number 2 is to use conditional probabilities formulas to calculate probabilities. Remember on the front, we had the 6 out of 10, and I wrote that was the probability of both over the probability of the given. Well, here it is with the conditional. And it's listed, and it's listed 2 other ways which are equivalent, they're just written differently. So the probability of both is the probability of A and B over the probability of the given, in which case that is the probability of B because this is the given. And then we write it a third way with the set notation with the intersection mark, which means the word and. So that's just a restatement of the formula above it, only using that symbol in place of the word and. And then determine whether 2 events are independent. All right, independent events occur when knowing whether or not one event occurs does not change the probability of the other event occurring. So that's our check. If we've determined the probability of the event A, it should be the same as the probability of A given that B occurred, because the fact that B occurred doesn't change the probability of A, or that it doesn't occur. So if you can make this work, then you can answer the question whether or not the event A and event B are independent of each other. Okay, so that's our learning targets. Let's look at the app. Who earns A's in college? So students at the University of New Hampshire received 10,000 course grades in a recent semester. The following two-way table breaks down these grades by which school of the university taught the course. Schools are liberal arts, engineering and physical sciences, or EPS for short, health and human services. Choose a University of New Hampshire course grade at random. Consider 2 events. Event E is the grade comes from an EPS course. So let's go ahead and call this event E. Now the other 2, liberal arts and health and human services, combined would be E complement. So I'm not going to write that in 2 different places. That'll be concerning. So if we're, say, given that a student is from the EPS school, then we would only concern ourselves with the values in this column. And the other 2 would be not E, if that makes sense. And then the grade is lower than a B. This would be we'll use L for that. So this will be L. So it'll either be lower than a B, which is this row, or it'll be L complement, which would be sort of these 2 rows put together. So it's either lower than a B or not. It's either from an EPS school or it's not. All right. Describe the probability of having a grade lower than a B given that the grade comes from engineering and physical sciences. So this will be the probability of L given E. And I've described it down here, which I'll read momentarily, but we're going to find this. And we're going to find it like so. We're going to have a kind of a complicated fraction because there are no grand totals or subtotals here. And keeping true to the notes, I don't want to put those in here because we're going to just work on it expanded. If it's given that this is from an EPS course, then we're only concerned with this column and we're not concerned with these 2 columns. So let me get rid of those. And okay. So we're going to just use this to figure out our new grand total. So 368 plus 432 plus 800, which would have given us a subtotal, which is missing. And so given that, our grade that's lower than a B is 800. So that is success out of total. Here's your grades that are from the EPS schools that are lower than a B. There are 800 of them out of the total for that school, which is going to be 800 out of 1600, which is 0.50. And that would give us a probability of 50%. So given that the grade comes from an EPS course, there's a 50% probability that is lower than a B. So we weren't looking at all of the grades, all 10,000. So that denominator is not 10,000. It only concerns us with this particular school. And there are only 800 grades, 1,600 grades there. So are events L and E independent? This is an interesting question. We already know that the probability of a grade lower than a B, given that it's from an EPS school, is 0.50. It came from up here. Let's go ahead and figure out the probability of a lower than a grade B, given that it does not come from an EPS school. Okay, this is going to make things sort of complicated. So if it's not coming from an EPS school, this is out. And we're concerning ourselves with all of what's not, what I did not strike out. So let's go with the denominator first. This denominator is going to be pretty heavy duty because we have to include this, 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 and this. So this will be 2142 plus 1890 plus 2268 plus 882. Now we're over in this column, plus 630 plus 588. Go ahead and fix that up a little bit. So 588. And that'll be over the two that are lower than a B. So it'll be, the numerator will be 2268 plus 588. So these are the total in the denominator of all the schools that are not EPS. And out of that, these two represent the successes, which are grades lower than a B. And this is going to give us and we'll just go straight to the decimal equivalent, 0.34. Do you notice how that and this are different? Because these probabilities are not equal, the events EPS course and grades lower than a B are not independent. Knowing that a grade comes from an EPS course increases the probability that it's lower than a B. So we can further see that dependency. If somebody were to walk in to the room and say, I attend this college and my grade was lower than a B, we would probably know from the difference in those proportions that they are more likely to have come from this college of the engineering and physical sciences. If those two proportions were the same, then we couldn't say that. We wouldn't know where they came from, or we wouldn't have an idea where they came from. We're not guaranteed that that grade lower than a B is from engineering and physical sciences, but we have an idea that could very well be, because there's a bigger percentage of people in that college getting grades lower than a B. So lastly, number 3, given that the course grade is not lower than a B, find the probability that it came from an EPS course. Let's go ahead and write this out in symbols. This is the probability of E, given that L complement. Right? Given the course grade is not lower than a B, L complement is not lower than a B. Find the probability that it came from an EPS course. There's your E. All right, so let's go ahead and set this up. And again, this is going to be a long fraction. So not lower than a B would be an A or a B. Okay, so that's going to be let's see, this, and this. I know I've mucked this up for earlier questions, but it's these 6 things. So here goes. 2142 plus 1890 plus 368 plus 432 plus, all right, now we're over here, 882 plus 630. Right, that's what we've been restricted to. We're not looking at this. We're just looking at these 6 up here. And the probability that it comes from an EPS course are those 2 here. So that would be 368 plus 432. All right, we just shrink all of that down. That'll end up being 800 out of 6,344, which is approximately 0.1261. So there it is. This one is a little bit trickier. We're into the heavy-duty stuff, so you may have to watch this again just to make sure you've picked up on everything. If for some reason you just are continually stuck and you need to sit down with me and we talk it through, make sure that you do that. I don't think I'm going to do a supplement to this. I think what I'm going to do for the final video, at least from the stuff that we did before break, will be to look at the practice 4.1 to 4.4 that we did before our quiz. So thanks for watching, and stand by for the next one.